Let's sketch this polynomial. Okay, first of all, let's look at this whole equation. The first thing I notice is that negative right here. And that means this polynomial has negative end behavior. And what negative end behavior means as x approaches positive infinity, y is going to approach negative infinity. That just means as x gets bigger and bigger and bigger and bigger and is going to infinity, all the y values are getting smaller and smaller and smaller, and they are going to negative infinity. So your polynomial will be pointing down. That's the first thing I notice. The second thing I want to look at is the degree. What is our degree? Well, we have a degree of 6 because we have 1, 2, 3, 4, 5, 6. This is not in standard form. You would have to multiply this all out, and when you did, you would have negative 3x to the 6 would be a leading coefficient plus a bunch of stuff. So negative 6 is an even degree, not an even function necessarily, but an even degree, and we have negative end behavior, so that means this guy is going to look like this. At the beginning and at the end, he's going to be pointing down. These are like upside down parabola arms, and a 6, which is an even number, will make both of these ends point in the same direction. All right, let's find some roots. All right, so the roots are pretty easy. What we're basically doing when we find roots is we are letting the y value equal 0, and we're saying what x's do that, and they come from here. So that's kind of like a little x, y chart, you know, so x, y. So when y is 0, we have 1, 2, 3, so we have degree 6, but we have 3 real roots. You can also call them complex roots. They're just not imaginary. So our 3 real roots are going to be at negative 2 from this guy. This root's going to give us negative 1, and this one is going to give us 1. So we can go ahead and place those roots. We have negative 2, 0 here, negative 1, 0 here, and 1, 0 here. Now we could just sketch it wildly, but it's always really nice just to get a little bit more information, and that information that we're going to get right now is the Y-intercept. So in order to find the Y-intercept, all you have to do is you let the x's be 0. So we're going to go in here and make this x 0, and this x 0, and this x 0, and then we're going to solve this to find the Y-intercept. So what does y equal? It equals negative 3 times 2 times 0 plus 1 cubed times 0 minus 1 squared. So y equals negative 3 times 2 times 1 times 1. So that means y equals negative 6. So when x is 0, y is negative 6. And we can put that beautiful point right here. So now to sketch the polynomial, we have all this beautiful information, and what we're going to do is we're always going to start at the end because we know the end behavior. Now remember, we do know the polynomial looks like this, so we could start at the beginning, but with bigger polynomials, it's just easier to start at the end. And we have to see what we do. At 1, don't forget, we bounce, so I'm going to put a little b here so I don't forget. And at negative 1, we wiggle, so I'm going to put a w here so I don't forget to wiggle through there. And then I'm going to draw it. So it's negative in behavior. I'm going to start down here at the bottom. I'm going to come up to this. I'm going to bounce right off that. I'm going to be sure I hit my y-intercept. I'm going to come and I'm going to wiggle, wiggle, wiggle through. And then I'm going to come back down. Now I don't know how high to go here, and that's okay. We're just sketching. All right, thanks.